It's Gareep Brar. Gareep, you stand up. A minute to say something, or?
All I'm saying is I'm your new farmer advisor. I'll be dealing with nut crops, and I recently graduated from the University of Florida at Gainesville, and it's my second month here, and I'm looking forward to working with you.
We're very excited to have you. All right, so they were giving me 25 minutes, and I gave them a scare that I wasn't going to show up for some reason, as always. Better late than never, right, Marcia? So we're going to move quickly through some of this, but basically we're going to talk about bloom time diseases and kind of what to do this year, because this is more of an atypical year, or maybe it's who knows what it is. I think every year is an atypical year, but we're looking towards a pretty dry bloom period. There is some rain in the forecast for later next week, but for the most part, the questions are now revolving around: do I need to spray, or should I even worry about it, and what should I be using? So the first thing to kind of think about is we always talk foliar diseases in the spring, or bloom time diseases in the spring, because rainy conditions favor disease. They require leaf wetness. So the petals need to be wet, the leaves need to be wet. Whenever we talk about foliar diseases, it requires leaf wetness. Flowers, on the other hand, are probably more susceptible than any part of the plant at any other given time. It's because it's a delicate tissue. It makes sense. It's supposed to be attracting pollinators. So these are probably, it's just like some of the fruit tissue as well. So this tissue is highly susceptible to fungi, and we have several different types of pathogens that we worry about. Now, when we think about control in regards to almond bloom diseases, we really have to think about not only the diseases at hand, but what fungicide we're planning to use, as well as the time and the coverage of these diseases, or of the fungicide spray. We always kind of consider this in the springtime, and we really focus on these three main diseases: brown rot, shot bolt, and jacket rot. We'll talk a little bit more. We'll talk a little bit about scab, but we're going to leave out pretty much rust and then alternaria and even hall rot, because these tend to be more summertime diseases, and we'll have another meeting in this series that we can cover these diseases. So let's focus a little bit on brown rot, and the reason why I think I think brown rot's bark is more than its bite, but it is dependent upon what varieties you have in your orchard. So if you're looking at a Butte Padre orchard, you're going to have more tendency for brown rot strikes than if you have, let's say, a Nonpareil, Monterey, Aldrich orchard. Those three varieties tend to be more resistant or more tolerant to brown rot than, let's say, Butte Padre. And Wood Colony, on the other hand, is in that Butte Padre category as well. So it's highly susceptible to brown rot. Infections move really quickly and rapidly through those varieties. But basically what happens is, the picture doesn't look that great, but I'll just make it up. You guys have to believe me here. The petals are infected. It moves through the petals, the anthers, the pistils. It moves through those floral parts. It moves down the blossom and moves into the wood. And that's where you get this persistence of the disease in the orchards within this canker. And you can see, you always can tell if it's brown rot because you'll see this green fuzz, or this gray fuzz, within the blossom of the flower, or within the blossom of the almond. And this is a peach problem as well, or any Prunus species. So you'll get this moved into the wood. It will persist within the almond wood, and you'll be dealing with that for continual seasons if the conditions are favoring it. And what I mean by in regards to susceptibility or tolerance to this pathogen, this is a Butte orchard, and you can see the stripes, the blossom blight stripes scattered throughout. And this was a conventional Butte orchard that missed the full bloom spray, and it had about 50% brown rot in a season with no rain. So it gives you an idea that Butte can be highly susceptible, highly susceptible depending upon the year. And now you're thinking, well, wait a minute here. You just told me not even a minute ago that you need leaf wetness for these diseases. How come we're getting brown rot in a no rain area? Well, think how much dew is out there in the morning. And that dew is providing the infection period. That's the leaf where that leaf wetness is coming from. So even in these dry years, there's still ample dew. Okay, so here's some fungicides that we can use for brown rot. We're by far the best spray timing is full bloom. A lot of people in a wet year will go a 2 bloom spray, a pink bud, or maybe a 5% bloom, and then a full bloom petal fall spray. There have been some concerns, especially with a lot of the issues in regards to bees and all the questions of various pesticides. And my traditionally favorite recommendation or advice for using fungicide for brown rot would be Rogawn oil. But we are starting to have some concerns in regards to bee safety with this product, as well as with the broad spectrums of Captan and Xyran. So what does that leave? That leaves us really with our Shrubby Learn group, our DMI group, which is FRAC 3, as well as our Vanguard and Scala, which I can't even pronounce that without tripping over my own tongue, so I'll just leave it at that. But I generally now, I always encourage people to think about their spray schedule from the beginning and all the way to the end, all the way till May or June when you're making that last fungicide. And so when you're thinking about brown rot and shot hole and these early springtime diseases, try to find a product that doesn't really have a fit anywhere else, because use it and rotate away from that chemistry. And one particular FRAC group is this Vanguard Scale group. It really is very effective on brown rot, on jacket rot, and shot hole, and really doesn't have much activity for other fungi down the way, mainly because of the labeling issues, not necessarily due to the chemistry of it. So that leaves open the Strobilurin, like your Pristines, and also your DMI, your propiconazole, those types of issues for later down. Okay, so a very common scene, especially in the spring, so we go through the petal fall period, we get a cold snap, which always seems to occur just to make sure you guys are up till 5 in the morning. And we come out in the orchard and we see stuff like this. How do we know if this is bacterial blast or brown rot? And the short answer is looking at other symptoms that we're seeing within the orchard. If we see that gray fuzz, it's brown rot. If we see these abnormally irregular shaped lesions probably scattered throughout the orchard or on the leaves, and we have the lack of that gray fuzz, it's probably bacterial blast. The reason why I bring it up, you can't control bacterial blast with the fungicide, so you don't have to worry about kicking yourself that you missed your spray time. It was probably due to that cold snap that occurred in the weather. See, I'm trying to make you guys sleep better at night. Okay, so once we kind of move out of the brown rot, which is a primary bloom disease, we start worrying about the diseases of these senescing tissues from the bloom period, as well as the young leaves that are starting to form. Again, more severe in wet weather, and usually your fungicide is going to give you about 2 weeks of protection, maybe 10 days if you have consistent rainfall within that period. So we're going to talk a little bit about jacket rot. And the reason I'm bringing that is it looks like we're going to have some rain coming up. But jacket rot is predominantly caused by botrytis, the second pathogen. You will see Monolinea sclerotinia in there. But botrytis seems to be the #1 issue we have, mainly because of our fungicide selection. I'll get to that in a minute. But this disease does a phenomenal job of infecting that dead tissue from the jacket and then moving on to the young green fruit and killing that fruit, causing drought. It really loves cooler temperatures, so anywhere between 55 and 65 degrees and wet weather. So that's where the botrytis really kind of kicks in. And it's going to give you that gray fuzz as well. To give you an idea what botrytis will look like, have you ever had strawberries that develop that grayish, blackish fuzz in your crisper? Or brownish fuzz? That was botrytis. It's the same pathogen for the most part. So in this one, we're really worried about these tight clustering forming varieties: Butte, Carmel, Merced, Avalon. Those really, oh boy, the list goes on. My mind went blank. But these real tight clusters is because this tissue is not able to drop off of the almond, so it stays in there, becomes infected, and then spreads to the green fruit. That's the process. It's more of a secondary infection that's moving to the green fruit. It's not a primary. It's an opportunistic infection or pathogen. The other thing to remember is this group of botrytis is not controlled very well with the DMI group, so that FRAC #3. So if you go out and you make an application of full bloom with propiconazole, which I know is the #1 probably product going out this year because of price, you're not going to have coverage for this pathogen. So if you come into a wet, rainy, cool weather, you would want to rotate away from that DMI group, that third DMI. Almond anthracnose, really it's becoming more and more of an issue, probably due to the late rains that we've had. I saw several orchards, Fritz variety in particular, just completely blasted with anthracnose. A lot of people will call you in saying, oh, it's leaf-footed plant bug, but it's not. The difference is leaf-footed plant bug, this gum will be clear. It's not going to be this orangish color that you see. Also, you see this nice, well, as a pathologist, you say beautiful, but you see this nice, devastating, sunken orange lesion on the hull of the almond, and that's the telltale sign. You'll have this, well, one side of the nut begin to shrivel, and then it will shrivel all the way through. It does a number on trees, and the more rain we get, and warm rain events really favor this disease. So 70 degrees and raining, sounds like that thunderstorm we had in June last year, the past couple of years. Those thunderstorms, those May and June thunderstorms do a phenomenal job of spreading this disease around the orchard. And again, like I said, Fritz is really susceptible. It moves into the spurs, moves into the branches, it'll persist on the mummy nuts, and that's where it's going to overwinter in your orchard. So it's going to, if you get this heavily infected in your orchard, automatically budget in another spray for the next year. To be honest, it's going to take a little bit of work to get the orchard cleaned up, and hopefully lack of late season rains. Okay, so fungicides for anthracnose, really relying on the Strobilurin group, as well as this DMI group, but you can get away with these broad spectrums. Of interest this year, it seems like people are becoming more interested in mixing in, starting off with like a Pristine or a propiconazole spray for their full bloom, then moving to like a chlorothalonil or a broad spectrum in that 2 to 5 week post petal fall. That gives you the ability to move back and move a stronger chemistry in for your scab or your anthracnose or something along those lines. But you still have activity on these pathogens at that timing. Okay, shot hole, I think we're all familiar with this. Gives you this fungus infects the leaf and the fruit. Essentially, it creates a hormone that causes that excision layer between the lesion, and the lesion will drop out, giving you a shot hole appearance. A heavily infected fruit will drop if it is infected, but those lesions also will fall out of that fruit as well. You can really tell if it's shot hole by looking for this little black fruiting body that's on the inside of the lesion. And it's going to be surrounded by a purplish margin. And the reason I'm pointing that out, I almost got ahead of myself. It overwinters on your greenwood, just like your scab. So it's going to be on that 1-year-old wood. Once you get past that 1-year-old wood, it's going to slough off those infections, and you're not going to have it persist. So it's really a follow-up year problem, just similar to scab. It's going to have that same overwintering location as scab on that green wood. Some chemistries, just about everything. I'll tell you, all the fungicides are rated on brown rot and shot hole. So if the chemistry is out on the market, it does a pretty good job of treating those two pathogens. This is a very abbreviated list. There's always more. You can dig deeper and find plus 3+ or 4+ control on shot hole with almost every fungicide. Okay, the reason why I bring up the fruiting body is because you guys are all cotton growers, and I know you love, most of you are old cotton growers, and you love spraying herbicides. So, how can you tell, maybe I'm generalizing, but I always see interesting symptoms when I come to this side. Gary, pay attention. How can you tell if it's shot hole or herbicide drift? So when you look at this leaf here, what do you guys think?
It's got both.
Both? This is, you look at this lesion, you can see you have that purplish margin, but there's no fruiting bodies present. And this is actually shark that's been drifted on the almond. You look at this one, what do you guys think on this one? Not shot. Well, so good guess, but this is gold drift. Gold will give you this yellow halo around the lesion or the almond. So something to kind of keep in mind. Here's another one. What do you guys think on that one? Bingo. Somebody hit that one on the head. This is Moxone on almonds. So you get this really distinctive dead lesion. This is a contact herbicide, so what it hit is going to give you cell death. Okay, what about this one? All right, bingo. You guys got that one. So this is shot hole. So you look on the underside, you can see the lesion, and look at that little black dot. That's that fruiting body that's of that disease. One last one. What about that one? Shot hole? This is a chemical burn. So this is from a grower who went in with this a little bit of zinc sulfate, a little bit of manganese, tried to make his own concoction of mineral and applied it to the tree, and we got a little bit of a rain, and then activated the cations within that that spray. So it can happen. This is the worst damage you saw. This on the new tissue. We didn't have any leaf drop, so life is good from this micronutrient spray. Okay, so we're going to move in and talk a little bit about scab, and then we're going to switch over after that. But here's the lesions of scab. I know we have all been familiar with this over the past couple of years. But this starts off as these small yellow clearings on the leaf as you're holding it up to the light. These clearings will eventually turn to a gray, tar-like spot. This again will survive on the green tissue, the 1-year-old wood, and it survives in these lesions that you tend to see. So,
Can I make one comment?
Yeah.
A lot of times, we talk about San Jose scale and sampling. And honestly, both this and I think it was Chicago, thanks. You can't pop that wax covering off. If that was scale, you can take that black area and actually use a knife and pop it off, and there'll be a little yellow body there. So I know when I first started, the diseases were tough to separate visually from San Jose scale. But just remember the scale, you can lift it up and you'll see the yellow body of the scale present.
and this, you can scratch this off, but you really have to work at it. And the reason why I'm bringing up these fruiting bodies is because this, see that fruiting body went from that light brown to the gray, and then now you have this black ring. That black ring is the spores of that fungus spreading into the orchard. So if you wanted to optimally time your scab spray, you time it when you start seeing these lesions get that black ring, that black circle. But that's somewhere between 2 and 5 weeks post-petal fall, depending upon weather. And with the persistence of some of the fungicides we use, we usually provide control at that time. That's why we have that spray timing in our chart. Always, you see 2 to 5 weeks post-petal fall for scab. That's where it comes from. It's based on the fruiting of that lesion. Okay, so we're aware of some of the damage. This is Carmel, a really susceptible variety to scab, but it doesn't. You can see here we had a lot of late season leaf drop. Pretty much by the time you see the symptoms pop up in the orchard, you're taking the back seat to that infection. You can make application of any fungicide you want, but you're really just throwing money after the problem, and it's not really going to prevent the issue that's really going to happen. So here you get this leaf drop, these buds re-push, and then the following year you come back and you can see that there's hardly any fruit bud that's developed on underneath of the canopy. It's all up a little higher where there's enough wind to blow it out. Therefore, complete severe loss of crop. Been in several orchards last year that have experienced that from the weather from 2011. Okay, so how do we go about controlling scab? No history of disease, so pretty much the prescription is to go through and make this application 2 to 5 weeks post-petal fall. This DMI and Strawberry Learn group are probably our most effective fungicides for this. You can see these are now being mixed together to give you more effective control. For example, Quadris Top is a FRAC group 3 and a FRAC 11 mixed together. That's why it's a pretty effective spray. If you're an organic grower, you're probably looking at micronized sulfur sprays throughout the summer months. If you have a history of the disease, so you were this guy, and you were this guy at the end of 2011, you could go through and make an application in dormant of copper and oil or chlorothalonil oil. Before bud swell with chlorothalonil oil, it's important to make that note, and burn back those lesions so you have less inoculum coming into the season. More fungicides, but these are available. Some things I want to point out is this year I'm getting the word that propiconazole going for $6 an acre, and it's a very tempting fungicide to use. It's very effective for brown rot and shot hole. Remember, it has that hole with jacket rot, but the weather stays good and not much of a concern there. But if you do decide to go that route, I would try to mix in a broad spectrum at that scab timing or that petal fall scab timing, depending upon weather, to try to get something in so you can come back in with a Strobilurin or a DMI later in the season. And you got to remember, now with these products, they're mixing several chemistries together. So you may be using a DMI without actually thinking you're using a DMI. So if you went in with bumper here or propiconazole here, and then you come back here with Quadris Top, you just went back to back with that FRAC 3. And we want to try to rotate away from these chemistries in order to have that persist within the operation. So I'm going to switch gears a little bit. So here's a picture of a bee loaded up with pollen coming into a flower. Going to hopefully do the job and set a net for us. But I'm going to talk a little bit, shift gears about pollen, protecting the pollen in order to prevent movement of some of these various insecticides and pesticides into the hive. But you can see that this bee is actively collecting pollen. This pollen is actively hissing from these anthers. And that's what we want to try to protect when we say protecting pollen. The bees will collect the pollen. They typically do, that's one of the first orders of business in the morning. And this protein, or this pollen has the protein that they feed to the developing brood. So when you hear of the bee collection, they're going to collect pollen, they're going to collect nectar. Nectar goes into the honey, which is used for the energy for the adult bees. Pollen is used for the protein for the developing larvae. So that's why we're concerned about protecting that pollen. So basically, we want to move through and we want to spray a little bit later in the day. Ideally, we want to spray when we're not seeing bees fly around with the sacks of pollen on them. But I know that's a little bit of effort to go out there and check. But generally, pollen bees will be further out on the flower. Nectar collectors will be going deeper into the nectaries of the flower. So that's another thing. If you see a bee inside the flower, most likely they're done collecting pollen for the day. Pollen is really, it will come out the first thing in the morning because it needs the humidity from the morning. It dehisces from the anther, gets pulled in, goes back to the hive. And what we found is most fungicides, Abound, Roveral, Elevate, and so on, actually can affect pollen germination. So if we spray this insecticide onto the anther, onto the pistil of the flower, and the pollen grain falls, and that fungicide is wet, it actually will inhibit the growth or the germination of that pollen. So we want to move our fungicides a little bit later so they have the time to dry before we actually have pollen falling onto the pistil of the flower, the female part of the flower. We've actually also have some evidence that suggests that certain fungicides are negatively impacting brood. So pollen contaminated with these fungicides coming back into the hive can actually reduce or slow the development of the brood, therefore impacting the health of the hive down the road. We're kind of moving. I know we're coming a little bit full circle on this, but I'll be honest that a lot of beekeepers, and as well as the universities across the United States, are pulling at strings in regards to this colony collapse disorder. They probably don't want to hear me say that, but in that regard, we're trying to advise a little bit better stewardship and getting the application of pesticides out and only apply them when needed during full bloom. So if we're able to make a single spray, that's great. But if we're making that spray, try to pull out those insecticides and move them to different timings in the year. Okay, switching gears. Any questions on that one? I saw a couple of heads give me a look there. All right. I gave these slides before, but you always hear us harp rotation, and I think Dave Haviland will talk about this in mites, as well as insects and herbicides. We always talk about rotation of chemistries. And basically, it's a numbers game. So when we look at this, if this orange population is this colony of this fungal colony, let's say scab, and this blue one is a resistant to this fungus. Excuse me, let me start over. These orange ones are colonies of scab that are susceptible to fungicide A, where this blue one is a colony of scab that's resistant to fungicide A. So when we make an application of this first fungicide, we'll kill most of the orange, but we're going to leave the blue behind, and it's going to be able to replicate and spread to the orchard. So if we go through here and make a second application when the population dynamics have shifted, if we end up using fungicide A again, we're going to select out for the orange, but we're going to leave the blue behind. So that population will continue to grow. If we rotate to a different chemistry, we'll be able to knock, hopefully, both of those populations back and bring the potential epidemic under control. So that's why we always kind of keep harping this resistance factor. And it allows us to have these chemistries persist longer. So there's a reason why propiconazole is $6 an acre. It's because it's off patent. And you have a lot of generics coming out to the market. Well, if we burn through that chemistry, we're now going to be relying on more expensive chemistries. So by rotating in different modes of action, we're able to have these chemistries persist much longer. We can do this rotation based off frac groups. We do this nice job of putting a number on the label. The idea is you don't use the same number back to back. You don't use a 3 and then a 3. This helps clear up the clutter of all these different trade names that we have. Okay, some more information on the UCIPM website. as well as I try to keep a weekly updated website on the Almond Doctor, as well as your local extension office, Go Hassel Gareed now, and hopefully your PCA is providing you with good guidance as well. So I appreciate your attention. Thank you.
Got time for just a couple of questions, and sorry for the darkness. Gary?
What is mistletoe?
Mistletoe is a parasitic plant. So what happens, it spreads from the seeds from birds eating the berries, and they land on the tree, and they, for the lack of better words, they crap it out into the branch, and then it grows into the plant. It actually grows roots into the branch of the tree, and it parasitizes and begins that vegetative state. The only thing it's taking from that tree, since it's green, that means it's actively photosynthesizing, is water and a little bit of nutrients. The only way to get rid of it is to kind of cut it out and cover it with some black paper. A good thing is that shingling paper they use, or that real thick black paper, you cover it with duct tape. It doesn't always work, but it's what we found to be the most effective in the setting.
Okay. Parasite, not fungus.
No, yeah, it's a plant parasite. Yeah,
Thanks.
no problem. Probably answered more than you wanted, right?
No, it grows so darn fast that you just can't let it grow.
No.
Yeah.
Can't. Other questions?
Have you heard that Pristine does anything to the bees, the brood?
So a lot of money has been spent on Pristine in regards to the bee brood. I think you'll probably be seeing some data coming out that will be vindicating Pristine from that bad reputation. But again, if we can all possibly reduce the amount of pesticides going out of bloom, we'll have less of these concerns coming up in the future. But I think Pristine's a good fungicide to use. It's a combination product of Boscalid and the Strawberry Learn group. And the evidence that I've been seeing is showing that it doesn't have a negative impact on bee brood. But that's soon to be coming out in a peer-reviewed publication as well. So that's not just me making it up.
Well, thank you, David. And one of the things I'd like to give a plug to, if you haven't gotten onto the Almond Doc, do Google it. You'll find it. You can get on his mailing list, and it's really a great weekly and sometimes several times a week, depending on the issues, of updates of what's going on in almonds. So really highly recommend that you get on to stay informed.
All right, thank you.
Okay, thank you, David.